Hi everyone, my name is Richa and the topic of my final project is classification of musical instrument by sound. The scope of this project is to build convolution neural network model that classifies musical instrument by sound using RAMS dataset. This is a huge dataset that contains 500 to 700 radio clips for 11 instruments. For this project, I considered 4 instruments: cello, flute, piano, and saxophone, and I trained the model using 250 audio clips in each category. To run this project and model, we need Python, TensorFlow, Keras, Librosa, NumPy, Jupyter, Plotly. I ran this code on Google Colab, so I was not required to install all these APIs separately. But if needed, they can be installed using simply simple pip command. To use Google Colab, anyone can go to this link. They'll have to create an account, and after that, they can use Google Colab. They can upload the notebook, they can write the code and run this either using GPU or CPU. Now we have many interesting and important audio features like log spectrogram, FFT fast Fourier transform, and MFCC. We can visualize these sound features. So I have created few plots here. This is the wave plot for 4 instruments: cello, piano, flute, saxophone. This is FFT plot. This is to assess the frequency distribution of the power in a sound, and this is MFCC plot. So MFCC is very important and useful feature in sound classification, in sound processing. The MFC is a representation of the short-term power spectrum of a sound based on a linear cosine transform of a log power spectrum on a non-linear Mealy scale of frequency. And this feature is considered very similar to what human hear. So for classification, I have used MFCC as a feature. And first, I used 12-dimension MFCC feature and tried to build CNN model, which gives me the best accuracy. And using 12 MFCC feature, I was able to obtain 54% as max accuracy. So to improve the accuracy, I further use 32 and 64 MFCC feature, and I also changed the CNN architecture to obtain the model which performs best. So 32 dimension MFCC gave me 59% accuracy, and with 64 MFCC, I was able to get 62% accuracy, and this was the best accuracy that I could get. This is the code for model that I used. Let's go to the demo. So as I mentioned, I used Google Colab to run this project. You can add a cell using code button here. It will create a cell and you can write code. Or if you already have a notebook, you can go to the file and upload notebook or open notebook from here. If you have any existing or open notebook, you can save that notebook in a drive, or you can download any notebook from all these options. So to run this project, you will need a test data set. The test data set should be in a format where the folder would say the instrument name, and under these folders we will have audio clips in a .wav format. So once you have downloaded the data, you to run that on a Google Colab, you'll have to zip it and upload it using this button. And after data is uploaded in Google Colab, that needs to be unzipped using this command. And once we unzip the zip file, we will see a folder created like this, and all subfolders will be shown here. Okay, so now once we have data uploaded, we can just go ahead and run these cells just like we do in Jupyter Notebook. These are the import statements for the required APIs. In this path, we need to give content and the folder name. This will search the data in this path, and it will read the audio clips, and it will further create feature sets. So these are the function which will create MFCC as a feature. And after we have created MFCC vectors. I have saved that in those in .mpy file. You can see that these files are created here corresponding to each instrument or each folder. And after that, we can read those files for MFCC features and accordingly create train and test data set that we will pass as an input to our CNN model. So this code will just create a feature vector, and it will give us X train, X test, Y train, and Y test. And after that, we need to reshape our data so that we can pass our data as an input to the CNN model. And this is the best, this is the architecture of the CNN model which gave me best accuracy. So as I mentioned, I used a 64 dimension MFCC, and it was a large feature set. So I had to reduce dimensionality to avoid overfitting, and for this particular feature set, I was able to obtain better accuracy with less number of layers. I used ReLU as an activation function, and learning rate 0.01, and SGD as an optimizer. And after that, I ran this model with early stopping. I used X test and Y test hot as a validation data, and I ran this for 250 epochs, validation steps 200, and 150 steps per epoch. And this function will give me a plot for validation and training loss. In all CNN model I ran, usually the training loss was more, validation loss was decreasing with epochs, but it was decreasing with much lower rate than the training. I tried changing the learning rate, and I was able to get the I was able to get better graph and better decrease rate, but not as better as we have that for training. And now this plot is showing the final accuracy of validation data for 250 epochs and with early stopping for 64 MFCC. So I reran the data. So this time I got 58%. With the earlier run, I was able to get 62%. Now these are the codes snippets, and this demonstrates the result. As I mentioned, the validation loss is not decreasing as better as it's decreasing for training, and this is the final accuracy. As I mentioned that I was able to get 62% with MFCC 64, and this screenshot shows that. Okay, so after this, to summarize this project, I was able to obtain model that gives moderate accuracy, 62%, but it was able to perform good prediction. But this model used 64 MFCC, which is a large feature set, and it is not best to use for large data set. And if we compare the accuracy and the cost, then it didn't increase the accuracy as much compared to the cost. So as a future scope, we can explore RNN, GAN, and try to build a model which yields better accuracy with less number of features at like 11, 12 MFCC. And we also need to explore other features which might be more useful in classification, like filter bank. So MFCCs are derived from the filter bank output. So filter bank contains more information, and probably they can be used to obtain better result than the MFCC. So that's the end of my presentation. Thank you so much, everyone.